farewell, creativity, work values, and evolution. David T. Lykken was brilliant and funny, frank and controversial. He enjoyed hearing other people's ideas and had many of his own, some hotly contested. He deprecated lie detection and advocated parental licensure, the issuing of permits to couples who met government standards for reproducing. Lykken was also a skilled writer and storyteller. He supplemented his scientific concepts and conclusions with real-life examples, many drawn from his experiences with the reared-apart twins. Lykken was also a clever methodologist. He showed how statistical power increased by 20% by studying twins reared apart versus twins reared together. In twin research, he was famous for introducing emergenesis, a concept he detailed in a 1992 article in American Psychologist that remains controversial to this day. Emergenesis, Lykken's legacy. Emergenesis refers to genetically influenced traits that do not run in families. Emergenic traits are thought to emerge out of complex configurations of polymorphic genes that come together by chance in an individual. According to Lykken, emergenesis explained extraordinary musical talent, mathematical ability, and athletic prowess in families in which musicians, mathematicians, and athletes were absent or ordinary. Individuals born in later generations would lack these talents, because genetic segregation would dissolve the gene combinations underlying the unusual trait. Lykken reasoned that such processes might explain Triple Crown champion Secretariat's running speed and Indian mathematician Srinivasa Ramanujan's numerical genius. Secretariat's speed surpassed that of his distinguished lineage, and Ramanujan owned just 2 math books, both in a foreign language. The skills of such horses and people may differ qualitatively, not just quantitatively, from those of others. Emergenic traits include any complex behavior that appears rarely in families, not just unusual talents or skills. The unique behaviors of several of our MZ twin pairs are illustrative of emergenic traits. There were female Kyo twins who giggled incessantly, female Kyo twins with affinities for dogs and horses, and male Kyo twins with outstanding mechanical skills. These male twins each separately diagnosed a faulty wheel bearing on Bouchard's car. Few DZ twins showed such similarities. Lykken noted that these observations were only suggestive in the context of discovery. 7. As I indicated, the important information was the marked mzada difference in the size of the intraclass correlation for a given behavior. That is, a high MZA, or MZT, correlation, coupled with a low DZ, or DZT, correlation, flagged a possibly emergenic trait. Lykken concluded that emergenic traits could only be detected with twin studies because MZ twins share all their genes, and consequently, their complex gene configurations, whereas DZ twins share only half their genes on average. It would be rare, though possible, for non-identical twins to inherit the same multigene combination. The MISTRA analyses suggested an emergenic quality to several of the twins' measured traits. These traits included the alpha mid-frequency, an electroencephalogram spectrum parameter, the well-being scale, from the multidimensional personality questionnaire, and the rate of electrodermal habituation, physiological response to loud sounds. Likken's studies of twins, reared together, added arts and crafts interests to the list of possible emergenic traits, and data from the Swedish reared apart twin studies added extroversion. In his 1992 paper, Licken included a section called Emergenesis versus Epistasis, probably anticipating objections from colleagues. Epistasis, a standard concept in genetics, refers to interactions among several non-allelic genes, genes located on different chromosomes or on different places within the same chromosome. In contrast, emergenesis goes beyond gene interaction to include a large number of genes and to describe observable features at the molar level, as configurations of partly genetic traits. Licken reasoned that most complex traits are quite a bit removed from specific genetic events, so emergenic characteristics can be thought of as composites of lower-level dispositions, working in concert with environments. For example, athletic talent may require a certain balance of speed, musculature, and motivation plus opportunities and training. One may think of emergenesis as epistasis writ large. Of course, major genetics advances have been made since 1992, especially with the unraveling of the human genome in 2001. Scientists are now searching for genes predisposing people to complex traits such as schizophrenia, autism, and cancer, with mixed success. Finding specific genes linked to these disorders is difficult because genes interact with each person's unique genetic background and environment, and there are many genes from which to choose. Licken speculated that chance combinations of genes underlying emergenic traits could be qualitative steps in the evolutionary process. Such emergenic evolution would require long time spans and would supplement, not replace, evolutionary changes linked to accumulating micromutations, small changes in DNA that may be harmful, beneficial, or neutral to the organism and population. Evolutionary perspectives on human behavior were gaining attention in the 1990s, and it was exciting to think that twins reared apart could contribute to this awareness. It turned out that Miza and Diza twins were valuable resources for testing other evolutionary-based hypotheses, as I will describe in this and subsequent chapters. Thus, emergenesis was an interesting and creative concept that generated new ideas about behavior and ways to test them. Earlier in this book, I suggested that comparing the different editions of Plumman's behavioral genetics could track progressive changes in the field. The 1990 edition did not reference emergenesis, but the three editions from 1997 and after did, calling it an extreme version of epistasis. 12 emergenesis is Licken's legacy, but epistasis remains a vital concept in genetic research. For example, models assessing the capacity of viruses to replicate in the absence and presence of drugs had greater predictive power if they included multiple epistatic effects, that is, interactions among mutated genes. Where multiple epistatic effects end and emergenesis begins is a key question. Reassessing creativity. Emergenesis showed up in a 1993 creativity paper from the project. This study was led by Niels Waller, the first author on the religiosity paper discussed in Chapter 7. Waller had been invited to comment on British psychologist Hans Eysenck's Target article on creativity, published in Psychological Inquiry in 1993.15. Eysenck viewed creativity as reflecting personality and cognitive factors working together interactively, rather than additively. At that time, twin studies had found low heritabilities for creative thinking, devising something new or original, and ideational fluency, producing ideas that meet certain requirements, but none had examined creative personality, displays of energy, flexibility, independence, sensitivity, and openness. In fact, creativity in any of its manifestations had never been studied in reared apart twins. The creative personality scale embedded within Harrison G. Goff's 300-word adjective checklist was completed by the reared apart twins. The scale is a 30-item measure of trait creativity based on responses from over 1,700 individuals, many from fields requiring creative activity. Twins endorsed items they believed were self-descriptive, for example, reflective and unconventional. Creativity data were available for 45 MSA twin pairs, 1 MSA triplet set, and 32 DISA twin pairs. The intraclass correlations were 0.54 MSA twins and 0.06 DISA twins. The marked twin group difference in the size of the correlations was consistent with emergenesis. Waller concluded that creativity was genetically influenced but did not run in families. Waller also challenged Eysenck's view of psychoticism as a creativity component because Eysenck's twin correlations did not fit the pattern expected for emergenic traits. Interests and talents. The continued development of the Minnesota Twin Registry and MISTRA enabled additional analyses combining twins reared apart and together. In 1993, Licken published the first Reared Apart, Reared Together twin study of interests and talents. A mostly environmental view of the origins of interests and talents was prevalent in the early 1990s. A 1991 paper by research psychologist Itamar Gatti indicated that genetic effects explained less than 5% of the variance in vocational interests. Our vocational interest paper by Dan Maloney, published the same year, moved the figure closer to 50%. Many other questions were addressed by Licken in the 1993 paper on the heritability of recreational interests, such as 1. Do vocational interests, leisure time interests, and talents intercorrelate, and do they produce interest factors? 2. Do MZT twin intraclass correlations provide good heritability estimates of interests and talents? Three, are interests and talents emergenic? The reared apart twin sample used in the interest analysis included 50 to 3 MSA twin pairs, 19 male and 34 female, 30. Six DZ twin pairs, 11 male and 25 female, and 1 MSA triplet set, male. The interest inventory was introduced into the study when it was already underway, so only about half the twins completed the forms in the laboratory. Twins who had been to Minnesota completed them at home and returned them by mail. The reared together twins sample included 924 twin pairs, in which 618 pairs were female and 524 pairs were MZ. These twins received an inventory packet by mail. A group of 198 pairs, 49 MZ male, 53 MZ female, 44 DZ male, and 52 DZ female, completed the forms again 3 years later. The composition of the reared together twin sample exemplified another of Lakin's contributions, known as the rule of 2/3. In 1987, Lakin showed that volunteer twin samples in many studies are generally composed of 2/3 MZ twins and 2/3 female twins. MZ twins may be more invested than DZ twins in being twins and in participating in twin-related activities. It is also well known that females are generally more willing research volunteers than males. The twins completed 4 different measures created by Lakin, 25. The occupational interest inventory included 100-item composites that tapped broad aspects of occupational interest, for example, skilled trades such as appliance repair, auto mechanics, and carpentry. Twins were told to assume equal pay and equal status across all occupational groups. They indicated like, dislike, or indifferent for each one, with regard to how much they would enjoy, the type of work, and that field's working conditions. 2. The Minnesota Leisure to Time Interest Test included 120 items describing a range of recreational activities, for example, fishing, enjoying nightlife, or going on safari. Assuming no time, money, age, or health limitations, twins indicated the frequency with which they would engage in such activities. 1 equal to never to 5 equal to as often as possible. 3. The Minnesota Talent Survey was a 40-item inventory of familiar talents. An example was carpentry. 1. You can make furniture, cabinets, etc. 2. You can hang a door, use power saws, build a doghouse, etc. 3. You can do minor repairs using hand tools. Or 4. You are unskilled with hammer or saw. Twins chose the alternative that best fit their self-perception. 4. The self-rating inventory consisted of 31 items concerning qualities not directly assessed by the first 3 measures. An example is abstract intelligence, the ability to solve intellectual problems, to understand complicated issues, to figure things out. Twins compared their traits and abilities to those of others on a 5-point scale. 1 equal to lowest 5% to 5 equal to highest 5%. In addition to these, the multi-dimensional personality questionnaire was available for all reared apart twins. This questionnaire was also included in the packet sent to reared together twins. The ranges and mean values of the intraclass correlations for the interest factor scores did not differ between reared-apart male and female twin pairs, so the data were combined. We found that genetic influence explained over 30% of the variance in occupational and leisure interests, whether we looked at the separate inventory items or at the factors composed of related clusters of these items. Organizing the data into larger scales and superfactors yielded average heritabilities of 48% and 53% respectively. The average intraclass correlations for the MZA and MZT twins were nearly identical at the item level 0.34 and 0.32 respectively. At the factor level, the MZT twins showed somewhat greater resemblance and less variability than the MZA twins. The average correlations were 0.49 and 0.42 respectively. A difference in the factor structure, derived from the reared together twin data, may have been responsible for this finding. Many MZA twins were raised outside the United States and may have had different interest opportunities. Overall, our results contrasted sharply with the less than 5% genetic contribution reported by Gotti 2 years earlier. Our results were also consistent with those from our 1991 vocational interest study. Likken's interest analysis was another successful effort at replication within the MISTRA. Each of the 3 questions posed at the beginning was answered. 1. Factor analysis organized the data into 39 factors and 11 superfactors. The superfactors and their reliabilities, interrelations among the test items, are listed in Table 9-1. 2. The MZT correlation appeared to be a more reliable and conservative estimate of heritability than the value obtained by doubling the difference between the MZT and DZT correlations. That is because the formula overestimates narrow heritability due to MZ twins shared non-additive genes. 3. Emergenesis characterized 67% of the 291 items and 62% of the 50 interest talent factors. Arts and crafts was exemplary. The MZT correlation was high, while the DZT correlation approached 0. Such traits would fit the definition of emergenesis. Table 9-1. 11 superfactors based on the 39 interest talent factors. Source: adapted from Licken et al., The Heritability of Interests, a Twin Study. Journal of Applied Psychology, 78, 1993, 649-661. Our answer to question 3 was especially interesting because many MZA twins' jobs and activities were similar but not exactly the same. The reared-apart twin firemen, Mark and Jerry, figure 9-1, both installed electrical equipment, but one worked with burglar alarms and the other with fire suppression systems. Both twins loved music, but Mark preferred rock and roll, and Jerry preferred country and western. Both twins were interested in forestry, but Mark had worked in the field, while Jerry had studied forestry at school. The twins were also football fans, although Mark favored the Dallas Cowboys and Jerry favored the Washington Redskins. The twins lived about 60 miles apart in New Jersey when they met, so their team preferences did not reflect their hometowns. The twins said that, despite these differences, they liked each other's styles. No one would claim that there is a gene predisposing individuals to favor burglar alarms over fire alarms, or the Dallas Cowboys over the Washington Redskins. Most important is that just by being themselves, Mark and Jerry showed exactly what Licken was talking about in his paper, the idea that particular interests seem less heritable than the dispositions underlying them. What persuaded Mark to take on forestry in an applied way, and what made Jerry pursue it in the classroom, probably reflected their non-shared experiences. A huge challenge for behavioral geneticists is to identify those non-shared experiences. Mark and Jerry also show that how twin researchers define similarities and differences, and whether they focus on specific traits or broad tendencies, affect heritability estimates. Licken also talked about a cafeteria of experience. Choice of experiences and reactions to them are partly determined by one's physique, ability, and temperament. But opportunities must also be available, and some opportunities may be more appealing at one time than another. Given the complex pathways from genes to behavior, it still amazes me that MZ twins can be so similar in what they do and what they like. But it is not their similarities alone that are impressive. It is their similarities relative to those of other genetically and environmentally related family members. It would be impossible to explain mesotwins' similarity in adopted siblings. Lack of similarity without reference to genetic factors. Interests and talents have certain qualities that make them important and meaningful to us. Our data also suggested that these same qualities extend to the work we choose to do. Our research exploring the origins of work values gave us insight into how and why we select some professions over others. Figure 9-1. Fireman twins Jerry Levy Left and Mark Newman were reunited in 1985 at age 31. A year later, Jerry is enjoying a Budweiser, the twins' favorite brand of beer. Note the pinky finger underneath the glass. Both twins held a glass this way. Photo credit Nancy L. Siegel. Workplace values. In 1992, theories about what people valued in their jobs focused on environmental events, such as family experiences and occupational socialization. Available theories at that time did not consider genetic influence, reflected by the empirical studies reporting environmental links between work values and gender, and education and experience. Together with our colleagues Richard Arvey and Lauren Keller, with whom we had collaborated previously, we analyzed the twins' work values. The sample included 23 MZ twin pairs and 20 DZ twin pairs. This sample was small relative to those included in other analyses we conducted at this time, because the inventory we used, the Minnesota Importance Questionnaire, was a late addition to the study. The questionnaire included 190 paired comparison items and 20 items requiring absolute judgments of the importance of each work outcome. Twins answered the paired comparisons with reference to the base question, which is more important in my ideal job. A sample item is A. I could be busy all the time, or B. The job would provide an opportunity for advancement. Twins also answered yes or no to absolute judgments with reference to the root phrase, on my ideal job, it is important that. A sample item to which they applied that phrase is, I could make decisions on my own. Twins also provided their current job so that we could assess the similarity of their occupations. 5 of the 32 twin pairs who provided this information held very similar jobs to their CO twin, and all were MZA pairs. We also coded the twins' jobs for occupational level or category, such as blue-collar versus white-collar, and other features. Blue-collar, for example, flight attendants, and white-collar, for example, attorney. Jobs differ, but they may be similar in complexity, such as in their hierarchies of authority and range of responsibilities. Similarly, two flight attendants or two attorneys may hold the same type of job, but their jobs may differ in terms of their number of bosses and assigned tasks. The twins' job levels were generally not the same. Both twins, in 4 out of 19 MZA pairs and 2 out of 13 DZA pairs, held blue-collar positions. These data were not complete, but it seemed unlikely that similarity in work values would be associated with similarity in job level. Previous studies had suggested that parents' socioeconomic status affected their children's work values. However, in their 1989 chapter on information processing, McGee and Bouchard showed that the co-twins' rearing parents' socioeconomic levels were not very similar. The present sample included a subset of the larger sample, so it was unlikely that this measure would influence twin resemblance in work values. However, within paired differences in parental socioeconomic status could lead to differences in work values. A twin from a high-status family might value creativity more than a CO twin from a lower-status family who might invest more in sick leave. The Minnesota Importance Questionnaire items were organized into 20 individual scales and 6-factor scales. The score variances did not differ between the MZA and DZA twins, but the mean autonomy score was significantly higher for the DZA than MZA twins. The DZA twins also scored higher than the MZA twins on the individual scales of activity, compensation, creativity, independence, and responsibility. If these were DZT twins, I might have explained this finding with reference to DZ twins generally lower investment in their twin relationship and possibly greater desire for individual achievement. There is no obvious explanation for these mean score differences in reared apart twins. The correlations for 5 of the 6-factor scales shown in Table 9-2 were significant for the MZ twins, but only one, achievement, was significant for the DZ twins. Correlations for 10 of the 20 individual scales were significant for the MZ twins, but only 2 were significant for the DZA twins. More striking were the median work value correlations of 0.42 for the MZ twins and 0.16 for the DZA twins, and the median individual scale correlations of 0.34 for the MZ twins and 0.20 for the DZA twins, not shown in the table. These results were our first indication that what we value at work is influenced partly by our genes. It was unfortunate that the Minnesota Importance Questionnaire was not available for a larger twin sample. The lack of statistical power may have explained why only 2 individual scale correlations company. Table 9-2. MZA and DZA intraclass correlations for the Minnesota Importance Questionnaire, MIQ, work value factor scales. Source, adapted from Keller et al., Work Values, Genetic and Environmental Influences, Journal of Applied Psychology 77, 1992, 79-88. Policies and Human Relations aspect of supervision showed a significant MZA-DZA difference. The heritability estimates, based on model fitting and corrected for attenuation, ranged from 0.37 altruism to 0.68 achievement, with a median estimate of 0.46. Our relatively low heritability for altruism was at odds with the 0.53 to 0.56 estimate reported in the literature. Perhaps our measure captured a different aspect of altruism or was less reliable. Our findings showed that approximately 60% of the variance in work values was tied to environmental factors and measurement error. People are not born with work values. These values must be acquired from work experiences and other life events. It may be that genetic factors underlying intellect, personality, and temperament predispose us to favor certain work outcomes and circumstances. It is also likely that job satisfaction, analyzed by members of our research team in 1989, is affected by how much work values are actualized while on the job, and whether opportunities are available to pursue one's ideal job. Our findings made sense considering the accumulating evidence of genetic influence on social and religious attitudes we saw in the literature as well as in our own studies. We felt that our results could help organizations and companies understand why improved work conditions and other perks may not be embraced with the same enthusiasm across employees. In June 2010, I asked our collaborator, Arvi, to reflect on these findings when I saw him at the International Congress of Twin Studies in Seoul. Like most researchers, Arvi described additional measures he wishes we had gathered from the twins. He was especially interested in details about the twins' work histories, such as those of the reared apart twin volunteer firemen Mark and Jerry. Calling the two men a rare base rate, Arvi wondered about the processes that independently led each twin to his job. Jerry, who had always wanted to be a fireman, had chased fire trucks as a child. Mark became interested in firefighting when his friends thought it would be fun to try, but he became committed to the service after saving a woman's life. Evolutionary perspectives. The new discipline of evolutionary psychology emerged out of sociobiology in the late 1980s and early 1990s. The key concept of sociobiology was that of natural selection acting through differential reproductive success. As such, sociobiology focused on fitness maximization, or behavior based largely on survival and gene transmission by reproduction. In contrast, as I explained in Chapter 5, evolutionary psychology is concerned with finding mechanisms that evolve to meet the challenges and demands of human existence, such as telling friends from foes and distinguishing safety from threat. Thus, it focuses mostly on explanations that consider behavioral and cognitive functions with reference to survival and reproduction. That is, ultimate explanations. However, explanations of behavior based on immediate causal events, proximal events that activate psychological mechanisms, also interest evolutionary psychologists. Evolutionary psychology and behavioral genetics have some common goals, yet their different foci have kept them largely apart. As described briefly in Chapter 5, evolutionary psychology is concerned mostly with species uniformities, whereas behavioral genetics is concerned mostly with individual differences. However, behavior geneticists have shown that virtually all measured traits display genetic variation, causing evolutionary psychologists to ask why meaningful genetic variation exists. Various explanations for trait variability have been proposed, such as mutations, gene changes, and non-additivity, genetic variance resulting from interaction among genes that is not eliminated by selection, and continue to be debated. Evolutionary psychologist and University of Minnesota graduate Stephen Gangestad believes that life history theory, the view that humans and non-humans direct environmental resources toward activities that will benefit their growth, survival, and reproduction, can offer answers. Behaviors that are optimal at one time may change as a function of environmental situations, nutritional availability, personal circumstances, an individual's age, and other factors. Human intellectual, personality, and hormonal systems have evolved such that certain behaviors are more favorable under some circumstances than others. There have been efforts to bring behavioral genetics and evolutionary psychology closer together. In 2001, Bouchard and University of Texas psychologist John Leyland attempted to reconcile evolutionary and behavioral genetic perspectives on personality. They suggested that basic emotions and motivations, such as anger, fear, nurturance, and curiosity, vary across a broad range because different levels of these traits would not be detrimental to fitness, except at the extremes where they would be selected against. Genetic variation in such traits could reflect the different environmental conditions that Gangestad discussed. Given the intellectual divide, few researchers attend meetings of both the Human Behavior and Evolution Society and the Behavior Genetics Association. This is unfortunate because 1. Behavioral genetics provides informative methods for testing evolutionary-based hypotheses, and 2. Evolutionary psychology offers behavioral genetics another theoretical perspective for interpreting findings. I was introduced to sociobiology in the late 1970s as a graduate student. My mentor at the University of Chicago, the late Daniel G. Friedman, was writing Human Sociobiology, a holistic approach at that time. Many of his students, including me, attended his informal weekly seminar on the subject. Friedman's book, published in 1979, appeared 4 years after E.O. Wilson's controversial book Sociobiology, The New Synthesis, which had given a name and set of concepts to a large body of research. Sociobiology was a comprehensive review of findings on sociality and made a strong case for a biological basis to social behavior. Wilson's last chapter on the biological basis of human social behavior became quite controversial. W. D. Hamilton's 1964 inclusive fitness theory of altruism. Altruism will be selected for when the behaviors benefiting a recipient exceed the cost to an actor. may have had the greatest impact on sociobiological and evolutionary psychological research of any scientific work in this area. Hamilton asserted that altruism should be directed more often toward close kin, that is, individuals likely to carry common alleles, than distant kin, as a way of indirectly transmitting one's genes to future generations. In general, one should be predisposed to help a sister over an aunt and an aunt over a cousin. Sisters share half their genes on average by descent, whereas nieces and aunts share 1/4 and cousins share 1/8. Hamilton defined inclusive fitness as an individual's reproductive success, enhanced by the individual's effects on relatives other than offspring. Of course, such behaviors would not occur consciously. No one helps anyone else for the purpose of preserving his or her own genes, but people act as though they do. Helping others feels good in an immediate sense. One reason why such behavior may be maintained. Identification of immediate events affecting the display and continuity of social closeness, cooperation, and other beneficial behaviors between relatives are also important. It seemed that using inclusive fitness theory to understand human social relationships would not detract from the significance of everyday influences on social behavior, but would provide another way of interpreting that behavior. The implications of Hamilton's reasoning for MZ and DZ twin relationships were striking. Perhaps MZ twins' unusual closeness could be understood in an ultimate sense. That is, it would pay to act more kindly toward one's MZ twin than one's DZ twin, because that would be like helping one's own genes. It would also add a Y to the twins' behavior. My 1982 doctoral dissertation, a study of cooperation, competition, and altruism between twins, was undertaken with these themes in mind. I always believed that twins reared apart would offer unique tests of evolutionary-based hypotheses. Canadian psychologists Chuck Crawford and Judith Anderson agreed, as shown in their 1989 article on the topic. They suggested grouping MZ twins according to hypotheses about specific behaviors or rearing conditions and comparing their developmental pathways. For example, some evolutionary psychologists have predicted that female sexual maturity should occur earlier in father-absent homes than in father-present homes. They have reasoned that it would be a better life history strategy for girls from father-absent homes to leave their disorganized environments to start families of their own. The idea of relating different behavioral outcomes to different life experiences is exactly what the Mistra was all about. Our goal, as stated in the introduction, was to identify associations between differences in the twins' life histories and the twins' behavioral differences. There were some wonderful opportunities to use the MZ and DZ twins in evolutionary-based analyses. The late evolutionary psychologist Linda Mealy claimed that for evolutionary psychologists, kinship, via the effect of inclusive fitness, constitutes a core construct of relevance to all social interaction. 42 twin studies exemplified this view, especially studies of social relationships between MZ and DZ co-twins, a topic I review in Chapter 12. Several years after arriving in Minnesota, I met Linda Mealy, a psychology professor at St. John's University in St. Cloud, Minnesota. She and I became close friends and colleagues, and continued our association after I left Minnesota for California. Linda was interested in how genetic and environmental variables affected reproduction, related variables, such as age at marriage and number of children. She asked Bouchard for access to the reared apart twin data, and he agreed. Bouchard was careful about releasing his files outside the department, but he was generous and encouraging when he trusted colleagues and believed they were serious about their work. In 1993, Linda and I published the first paper analyzing reared apart twin data in the context of evolutionary theory. We showed that while some behaviors related to reproduction may be genetically influenced, they do not affect the number of children. Our sample included 55 mesotwin pairs and 27 DZA same-sex twin pairs. The mean ages were 38.2 years, standard deviation SD, equal to 14.5 for the males and 42.2 years. SD equal to 10.7 for the females, so not all twins had completed their reproductive years. The twins had also been raised in modern societies that had transitioned from high fertility and mortality to low fertility and mortality, probably reducing the variance of some measures. Small, statistically significant relationships may have been larger without these constraints. Linda and I drew our data from the life history interview and the Briggs life history form. The intra-class correlations for our 7 outcome measures are displayed in Table 9-3. These values suggested that genetic factors influenced age at first marriage. It turned out that place of birth, a factor that naturally is constant for co-twins, had a significant effect on age at first marriage. Genetic effects were also suggested for age at first date, paralleling what we found for age at first marriage and what others have found for age at first intercourse. Among males, age at first marriage was also associated with parents' religious affiliation. The high DZA correlations for timing of children suggested an environmental effect outside the family, but shared by the twins. Perhaps the prevailing cultural expectation was that people should start their families by a certain age. The lack of genetic influence on number of children surprised me. When Linda and I began our work, there were no twin studies on family size. In later years, twin studies estimated the heritabilities for number of children to be 0.3% for males and 0.3% for females. Our goal, mostly exploratory, was to see if personality and health characteristics, for example, extroversion and teenage health, were related to reproductive events, for example, age at first child and number of children. The individual findings from that study were less meaningful than the big picture. Our data suggested that males' reproduction-related behaviors were more affected by genetically influenced measures of personality and health than were females. For example, in males, later age at first marriage was associated with low activity level, 0.35, and poor childhood health, 0.44. Table 9.3, intra-class correlations for reproduction outcome measures. Note: N equal to pairs. Source: adapted from Mealy and Siegel, heritable and environmental variables affect reproduction-related behaviors, but not ultimate reproductive success, personality, and individual differences. 14, 1993, 783 to 794. Females' reproductive outcomes were influenced more by family dynamics than were the males. For example, females with multiple marriages had experienced parent-child conflict (ICT) and family instability. The only important reproduction variable, reproductive success, was directly related to childhood health and only for males. The outcomes of our study conform to evolutionary-based predictions. That is, males are more likely to have their reproductive capacities reduced under adverse conditions such as poor health than are females. Males with less favorable sexually dimorphic characteristics are also less likely to attract potential mates than males with favorable characteristics. Thus, we concluded that while proximal or immediate developmental mechanisms may have evolved in accordance with evolutionary expectations, they might not be relevant in modern societies. The MR researchers completed other evolutionary-based analyses of the reared-apart twin data during the study's later years and beyond. It was important to incorporate this perspective into our work because of rapidly growing interest in this area. Bouchard tells people that he started studying evolutionary psychology because I encouraged him to. He was only partly right. He also knew that it was becoming an important perspective in the field, one that would add meaning to our phi endings. In fact, the word evolution eventually appeared in the titles of 7 of our publications. Evolutionary considerations were also discussed in other papers, such as Lakin's Emergenesis paper reviewed previously, and our 1990 IQ paper published in Science. My friend Linda Mealy passed away in 2002 at the age of 47. Her condition was diagnosed as cancer, and it spread quickly. I still resist the urge to call her when interesting topics arise, especially related to twins. Personality and cognition. Invitations to write book chapters increase when laboratories are productive. The growing number of empirical papers from the MISTRA probably led to the 1993 publication of several chapters and a book, Twins as a Tool of Behavioral Genetics, co-edited by Bouchard and German geneticist Peter Propping. Because Bouchard's chapters on personality and intelligence published in other collected works surveyed many studies in the field, not just the MISTRA, they will not be reviewed here in full. Instead, I have summarized them briefly, highlighting material on the reared-apart twins. Some of the MISTRA phi endings reported in the chapters were new because they were preliminary analyses, on their way to becoming full-length papers. Sometimes older data were used in new ways. Bouchard authored an overview of genetic and environmental influence on adult personality in a volume edited by Jupe Hedema and Ian Deary. The first part of his 2-part treatise summarized the major model-fitting results from twin, adoption, and extended family studies on the Big Five personality traits. The Big Five emerged as a dominant personality paradigm in the early 1990s. Big Five traits are easy to remember. If you think of ocean, openness, imaginative, inventive versus narrow, simple, conscientiousness, organized, efficient versus disorderly, careless, extroversion, sociable, dominant versus retiring, withdrawn, agreeableness, cooperative, sympathetic versus quarrelsome, cold, and neuroticism, calm, stable versus distraught, unstable. The second part of his chapter critiqued material that has been discussed throughout this book, so I will focus on the first part of his chapter. The first of Bouchard's two tables displays model-fitting results from a meta-analysis of reared-apart twin data from Minnesota and Sweden, an analysis originally done by John Leyland, Table 9-4. Shared family environments make modest contributions in both models. The data also showed the difficulty in choosing between models requiring special twin and sibling environment parameters and non-additive genetic effects. Special twin and sibling effects occur when the behavior of one twin or sibling affects the behavior of a co-twin or co-sibling. The late behavioral geneticist David Rowe also observed sibling mutual influence. Pairs of same-sex non-twin brothers and sisters who liked each other or shared friends were more alike in delinquency than those who disliked each other or did not share friends. Bouchard's second table showed the MZA, MZT, DZA, and DZT Big Five correlations based on personality data from a Swedish twin study and various samples from the Minnesota reared apart and reared together. Table 9-4. Alternative models for twin data on the Big Five personality traits. Source: adapted from Bouchard, Genetic and Environmental Influences on Adult Personality, Evaluating the Evidence in Foundations of Personality, ed. P. Jupetema and Ian Deary, 15-44, Dordrecht, Kluwer, 1993. Twin Studies. Table 9-5 shows only the weighted mean correlations based on these samples. The MZA data suggested an average heritability of about 0.50, and the lack of difference between the MZA and MZT twins suggested a shared environmental effect of 0. However, the 0.50 heritability left plenty of room for environmental influences unique to individuals. Non-additive genetic effects were indicated for extroversion and neuroticism because the DZA and DZT correlations were less than half the MZA and MZT correlations, suggesting emergenic effects on these traits. Bouchard often said that the absence of shared environmental effects on personality was counterintuitive, but true. It was certainly one of the most provocative and controversial findings from our study. The fact that other investigators were finding the same thing using other instruments and samples increased our confidence in the findings. I accept these results, based as they are on the twin self-reports. We also asked the twin spouses and companions to complete the adjective checklist to describe the twins' personality, information that is not yet analyzed. It is likely that these data would have shown somewhat less MZA co-twin similarity than that found from the twins' self-reports. A previous REARED Together twin study reported that peer ratings of the twins' personalities indicated genetic influence across the different traits, although less than that derived from the twins' self-ratings. If the twins had rated themselves relative to their co-twins, I wonder if we would have captured what Shields suggested that MZA twins are more alike than MZT twins on some personality traits, because MZA twins did not develop social roles within their twinship. as I've written. Table 9-5. Weighted mean correlations for the Big Five personality traits for Minnesota twins reared apart and together. Note, the combined samples included the following pairs: MZA, N equal to 61, DZA 42, MZT, N equal to 99, and DZT, N equal to 99, who completed the California Psychological Inventory, and MZA, N equal to 52, DZA, N equal to 33, MZT, N equal to 553, and DZT, N equal to 459, who completed the multidimensional personality questionnaire. Source: adapted from Bouchard, Genetic and Environmental Influences on Adult Personality, Evaluating the Evidence in Foundations of Personality, ed. P. Jupe Hedema and Ian Deary, 15-44, Dordecht, Kluwer, 1993. Elsewhere in this book, people interacting with twins usually find that twins behave more similarly when they are apart than when they are together. However, we did not detect this effect in the MISTRA self-report personality data. Plomin and McClern's Nature, Nurture, and Psychology summarized major behavior genetics advances that had occurred during the previous decade. At its 1992 meeting, the American Psychological Association had named genetics as one of the themes that best reflected present and future psychological research. The MISTRA probably had a lot to do with that. The book's editors wrote that McGu's chapter fell within what they considered the front lines of genetics research. 55. A striking feature is the series of graphs reproduced in Figure 9-2 that show IQ interclass correlations from past and present reared-apart twin studies. The correlations ranged between 0.64 and 0.74 for the three previous studies, and 0.69 and 0.78 for the more recent MISTRA and Swedish studies. The weighted average correlation was 0.73, using a total of 162 Mensa twin pairs. The similar finding based on the three earlier. Figure 9-2. Meza twin IQ correlations from 5 studies, adapted from McQuay et al., Behavioral Genetics of Cognitive Ability, a Lifespan Perspective, in Nature, Nurture, and Psychology, ed. Robert Plomin, and Gerald E. McClern, 59-76, Washington, D.C., American Psychological Association, 1993. Note, bars at the top indicate standard errors. Studies in the MISTRA was robust, as I indicated in Chapter 5, but it was more so with the addition of the 45 Swedish pairs. The MZ twin correlation directly estimates heritability. Thus, McGee noted that IQ heritability was about 75%, considerably higher than the 50% figure provided by other kin comparisons, because most MZ twins were adults, and because the results were consistent across studies. He concluded that the large MZ-IQ correlation probably reflected increased genetic influence over time, rather than biased sampling or assessment. McHugh's reasoning fits nicely with my own work on virtual twins, the same age-unrelated pairs I have been studying since the early 1990s. The virtual twin IQ correlation, which directly estimates shared environmental effects on behavior, is 0.28, N equal to 140, leaving the remaining 0.7% accounted for by genetic factors, non-shared environmental factors, and measurement error. These results appear to mirror those from the MZA twins for the following reason. Recall that a subgroup of the virtual twins, n equal to 43 pairs, who were very young children when I first studied them, showed a drop in their IQ correlation from 0.30 to 0.11 at their second testing in later childhood. This change suggested a reduction in shared environmental effects on IQ over time, with both genetic and unique environmental factors becoming more important. It is likely that when virtual twins are assessed as adolescents and adults, their IQ correlation will approach zero, as reported in other adoption studies. If this were the case, it would correspond to the MZA IQ findings of about 0.75 genetic and 0.25 non-shared environmental variance plus error. However, based on accumulated studies of twins and other kinships, a more accurate partitioning of adult IQ variance may be 60% genetic, 35% non-shared environmental, and 5% measurement error. Bouchard's 1993 chapter. The genetic architecture of human intelligence did not include new MISTRA twin data. Instead, it provided evidence supporting a hierarchical structure of approximately 10 primary abilities with 3 major peaks: general visualization, fluid intelligence, and crystallized intelligence, with general intelligence at the top. General visualization refers to mental manipulation of figural information, fluid intelligence refers to genetically based abilities, and crystallized intelligence refers to skills acquired through education and experience. Memory span and vocabulary are examples of the 10 primary mental abilities that cluster under their relevant factors, that is, fluid intelligence and crystallized intelligence, respectively. Bouchard also called for meta-analytic studies of intelligence and an end to ad hoc criticism of individual studies. In this context, he revisited some of the objections to his reared-apart twin studies that I detailed in earlier chapters, most notably Chapter 3. Bouchard and Propping's book, Twins as a Tool of Behavioral Genetics, focused on what twin studies had revealed about general intelligence and personality traits. It resulted from a 1992 Dahlem workshop held in Berlin on the subject. What are the mechanisms mediating the genetic and environmental determinants of behavior? Dahlem conferences are unique in that background papers, written around discussion topics, serve as the basis for small group discussions. MISTRA data were not presented, but some interesting historical notes on twins were embedded within Bouchard and Propping's introduction. They wrote that the idea of studying twins went back many years, to before Galton's time. St. Augustine, in the City of God, used twins to refute astrological claims. But, as discussed earlier, it was Sir Francis Galton, who is famous for developing the twin method for formal scientific inquiry in 1875, 62, 1992 to 1993. In August 1993, we began our collaboration with colleagues at the John Mayer U.S. Department of Agriculture Human Nutrition Research Center on Aging, Energy Metabolism Laboratory at Tufts University. Now twins would fly from Minneapolis to Boston to complete a 5-day analysis of body size measures, food intake, and energy expenditure. This 5-year study, funded for $1 million by the U.S. Department of Health and Human Services, assured us that separated twins would continue to be identified and assessed. Finding financial support was always our biggest difficulty, as is described in Chapter 14, and we never knew if the study would continue for 2 years or 1 year or at all. We added 5 new twin pairs to the study in 1993, 2 EMSA and 3 DZA opposite sex sets, as well as 4 spouses and partners. We also studied 7 follow-up twin pairs, 4 EMSA and 3 DZA, as well as 4 spouses. We presented 17 conference papers and invited lectures. In California, I began working on twin studies of odor identification and sensitivity using the University of Pennsylvania Smell Identification Test. I sent forms to Minnesota for the reared apart twins to complete. The first reared apart female twin pair I had studied in 1982 was one of the 4 EMSA twin pairs who returned to Minnesota in 1993. The twins sent me their photographs, and it was striking but not surprising to see how alike they still looked and how similarly they had aged. The twins reminded me of a photo Bouchard had hung in all of his offices, showing a pair of beautiful elderly MZ female twins, figure 9-3. The photo had been a gift from identical twin photographers, Catherine M. Abbey and Frances M. Gill, and had appeared in their stunning volume, Twins on Twins. Better than any study, the picture captures essential elements of the aging process. The graying hair and matching creases in their skin suggest that physical changes are largely influenced by genetic factors. A small inset of the twins looking so similar at a younger age underlines the idea of genetically based physical development, similar to what I noticed about the Minnesota pair. Bouchard loved this photograph, and he relished photographing reared apart twins beside it. Abbey and Gill also gave Bouchard a unique set of slides showing themselves together at many different ages. The images of these twins as infants. Figure 9-3, Bouchard's favorite photo. Identical twins Genevieve and Eloise Reed at age 94. Photo courtesy Catherine M. Abbey. Figure 9-4. Mza twins Keith, left, and Jake as infants. At age 11 or 12, Keith, and 10, Jake. At age 24 on their first assessment day in Minnesota, and at age 55 during a taped interview for Keith's son's school project. Keith is right-handed and Jake is left-handed. Note the opposite positioning of the handles of the twins' coffee cups. Photos infant, childhood, and adult years, courtesy of Keith and Jake. Photo credit Minnesota study, Thomas J. Bouchard, Jr. children, young women, and beyond suggested a rare time-lapse photography in which the individual ages before viewers' eyes. In this case, it was two individuals, and they were growing up exactly the same way. Bouchard often opened his twin lectures with these slides, which regularly captivated his audiences. When we positioned the MZ twins' separately shot childhood and adult photos next to each other, we saw the same thing. The genetically nuanced unfolding of physical growth and development is well known, but MZ twins make this process especially striking, as shown in Figure 9.4.